I believe. Oh, right. Brady Bunch for you. There you go. There's everybody. And we want that. Wait, no, that's not it. That's it. Perfect. Let's see if this works, if this functions. So we've convinced, we've now officially convinced our local brewery to do a Trappist 1 party. So they're making a special cask of just a Belgian double or a Belgian single. I haven't really decided which one it's going to be. And then we're all going to celebrate Trappist 1. So if you live on Vancouver Island, want to come hang out with us?
You know what they should do?
I'm buying the beer.
They should commission seven collector's labels, and you get like a special discount or something if you collect all 7.
Well, since I brought it up in a video, people have told me all about it now, so I'm definitely a lot more aware of how the whole Trappist situation exists. Not the planets, just the way the beers are made.
Kimberly, would you have to drink all 7 of those beers in one visit in order to get the full set?
I don't know.
Or you could buy a set, and maybe one for the star as well.
You could buy a commemorative set. There you go. Lots of money.
Yeah, but then you didn't really earn it.
All right, everybody watching live, you had your chance to say hello to me, so I'm going to say hello to you. Hey to Borat Klankar and Connor Lennon and Douglas Crandall, Yuriko Roberto, Giselle Sabrin, Guido Bibra, Henrik Bo Anderson, James Aberson, James Haney, Yan Dryak, or is it Jan? I bet it's Yan. John Gallant, John Suffield, Kenneth Lepre, Larry Beckham, Linda Sadek, Malcolm Bond, Michael Jobin, Mike Horn, Nancy Graziano, Patrick Sullivan, Paul Gracie, Peter Schultz, PsychoCat749, Quickie Koala, Rick Schwartz, Ronald McCoy, Sylvan Westby, Tak Tang, Thomas Tranneker, oh, Stealth DJ just snuck in there, Zach Cody, and Zap Van Zapfine. Hey, everybody, welcome to the Weekly Space Hangout. Lean on the like button, folks, says James Haney. Exactly right. So we did something kind of fun this week. I thought it was neat. We did a live premiere of our latest episode of The Guide to Space on Monday? Tuesday? Anyway, did a live showing of it, premiere. So it wasn't on our feed yet. And then I stuck around and answered questions for the rest of the hour, which was a lot of fun. So I think we'll do that again. I need to figure out how to do that. But it was neat to have sort of a bunch of people there live and we answer questions. So 3 more minutes. What's going on? How y'all doing?
Great. Happy Friday.
Good.
Billy Gordon thought he missed the show again. So remember, if you want to participate in the chat, now I've got to go down through Paul Matt Sutter to the chat down below. But if you want to join the chat, that is the Weekly Space Hangout crew. Just go to wshcrew.space and join the community. Like if you watch this show on a regular basis and you're not part of the Space Hangout crew, I don't understand.
Word.
I'm
never saying that again, but
again.
Saying that once.
I say that all the time.
Word.
I can't.
Word.
I do. I got to get out of
I'm
that.
not cool enough for it. Maybe you.
Of course you are. Of course you are.
Yeah. Because it's just like, I mean, there's a thriving conversation. I'm looking at it right now. You can't see it because you haven't just joined it, but it's free to join. They're great people. They're super space fans. And when you do, then you get to be an executive producer of this show. You're our boss. You go out, find guests, bring them home, and I will interview them. It's that easy. So, Sylvan Westby says, if you don't like the show, give it a big fat thumbs down because it's still a sign of strong involvement to YouTube. So even that one helps a lot. Really?
Yeah, YouTube doesn't care. YouTube cares about activity, not about thumbs up, thumbs down, positive comment, negative comment.
Yeah.
Want to see stuff happen.
So
you're confusing that with Facebook.
But what about us? We're human. You mean YouTube doesn't care, but we care, and it makes us sad.
Soon this show will be nothing but robots anyway, and then it won't matter what you do.
Hopefully, we're the last people to be
That's so
replaced by
sad.
robots. We will be, we will be the last people who can be replaced. And then I, for one, welcome our robot space communication overlords.
Don't worry, I'm hard at work at Fraser bot.
Oh, good. All right. Well, I think we should do this thing. It is the March the 10th. All right. You all get back into your corners. Oh, all palm, etc. all the time. All right. Focus on me.
I don't see a problem with that.
What about me? All right, here we go. Hello, everyone, and welcome to the Weekly Space Hangout for Friday, March 10th, 2017. I'm Fraser Cain, publisher of Universe Today. This week, we've got a bunch of stuff. We're going to be checking out some new images of Pan, the origin of the Milky Way's Fermi bubbles. I don't even know what that means. Update on the Europa Clipper. We're going to Europa. Ancient Stardust detected in a distant galaxy. Blue Origins update. They're going to be sending Amazon packages to the moon. And a new date for the first reused SpaceX rocket. So, joining us this week, we've got our regular cast and crew and a special guest. First, I'm going to start with Dr. Paul Metz-Sutter. Welcome to the show, Paul Metz-Sutter.
How's it going, Fraser?
Good. Paul and I just did a collaboration. Paul attempted to explain the holographic universe to me. That's going to be showing up in the feed sometime next week.
And I did an excellent job.
You did an excellent job. I don't know if my brain was up for it, so we'll see what happens.
You asked for it, man.
I really did. Well, I didn't ask for it. The fans asked for it. I am merely their humble vessel to ask those questions to you. I'm like a middleman. Joining us this week as well, we've got Kimberly Cartier. Kimberly.
Hello, Fraser. Happy Friday, everyone.
Every Friday's happy. And last but not least, Morgan Renberg. Morgan.
Kimberly stole my line.
What, the happy Friday? All right.
That's what you get for Fraser picking me first.
Oh, really? Oh, did I not?
Morgan can go first next time.
You're second in the round of the stories today, so I think that's good. Okay. Morgan goes last.
I can deal
with that. First. Anyway, and then we've got a special guest this week, which is Nic DiPalma. Nic, welcome to the show.
Hey, thank you very much for having me. And I'm going to say it again, even though Kim said it, but happy Friday, everybody. You've all earned your weekend, so congratulations.
Awesome. So, wait a minute. Who are you and what do you do?
So again, my name is Nic DiPalma, but I'm the founder and CEO of a company called Spacetime Labs, the first creative agency for science. We're a team of award-winning designers and producers and developers creating brand and communication strategies, digital content, and user experiences for the science community.
Can you give us some examples?
Well, as a little bit of a background, for the last 20 years or so, I've been a creative director, a designer, and an entrepreneur in educational media, public television, broadcast cable news, brand marketing strategy, and user experience design for web and mobile. And I've worked with a bunch of different startups, global brands, federal agencies, and nonprofits. So I want to help scientists now, taking what I've learned, what I have done, those expertise, and helping researchers and scientists engage the public for deeper connection, building greater support. It is taking a research story, your research story, and creating experiences for the public to engage, for the public to learn. Fans equals funds. So
fans equals funds, really?
Fans equal funds. Support.
Let me just check my bank account. Hold on a second.
Yeah. Well, maybe you're not asking them the right questions yet, and that's one of those things too that is very, very important when you have this incredible support, which you do, and a lot of your viewers do. Is that you need to ask them to show that support. And it doesn't necessarily have to be in the form of a check or dollars or financially. Maybe it's sharing and spreading the word. Maybe it's helping people sign up and subscribe to your YouTube channel or become a subscriber at Universe Today. Mm-hmm. how, in order to engage people, the most important thing that I try to tell scientists is engaging conversation.
So one of the things that we live in this world where now scientists are encouraged to communicate and share what they're doing with the public. But I know that back in Carl Sagan's day, he took a ton of grief from scientists, from his, from other people working in this, that explaining and reaching out to the public was beneath them, that this was not something that they should do, and yet clearly there's been sort of a sea change in the perspective of that. What is sort of the common thinking at this point in how scientists should be reaching out and engaging with the public?
Well, and I don't know if common thinking is even the best way to look at it, and I think that for scientists who feel that tremendous load of responsibility to do that is an awful lot. And I think because of great celebrities that we've had over the last 20, 30 some odd years, Carl Sagan, Neil deGrasse Tyson, Michio Kaku, Brian Greene, we cannot expect every scientist to be that level of celebrity in talking about their science. And I think by asking them to be great presenters, great speakers, great designers, great social media strategists, scientists don't necessarily understand brand strategy, those kind of things. I mean, we do ask an awful lot from them, which is why I found this opportunity to kind of be, dare I say, an advocate, our company our agency to help scientists create those experiences, the digital content, whether it's video, ebooks, infographics, websites, social media pages, and how all of that integrates. It's very similar to the business world in that businesses are not, the primary goal of a business is not to make money. Money is the result, right? The primary goal of a business is to create value. You have to create value before you can generate any kind of revenue or profit and those kind of things. And that same idea applies to science, that in order to develop that fan base with science fans and other people in the public, is to create something that connects with them, and not necessarily just their values, but also their identity. But
I think as you sort of said, being a scientist is your work, is your full-time job, and literally anything that you do that takes away from that really takes away from what needs to be a fairly deep, mentally intensive job. And of the celebrity scientists that I know they don't have a lot of time to do their science anymore. I know that even Dr. Pamela Gay, my co-host with Astronomy Cast, she deals with this push-pull. On the one hand, she's helping popularize science. On the other hand, she's trying to do original research work. Phil Plait, bad astronomer, he eventually left his research work and is full-time popularizing. And same, Neil deGrasse Tyson keeps one foot in research, but really he's full-time popularizer as well. So is it an either or?
I think that's kind of an individual thing. I don't know if we can kind of use the same brush for all of them, and certainly not for the same science. And for different practices in science, both applied and basic. And I think you kind of go to where you, and pardon the term, where you're bleeding the most right now, where we see the numbers of the funding for basic science is just shrinking and shrinking and shrinking and shrinking. So maybe it's those scientists that are able, that are capable, that are interested, and have the opportunity to become those very public spokespersons. Absolutely, if you want to help your research and your industry thrive, that's a role that you may have to play for a while. Maybe it's a fellowship, or think of it in that way, or a hiatus from the research and your team, so that you can get out there in the public, everything from school kids all the way to your grandparents, and be communicating about how important that science is and how they can get engaged and support that science, while your colleagues still work in the lab, and you're the one telling them about the great work they're doing.
I mean, one of the things as well is that I think the way science is funded most scientists really just have one customer. They have, or however, whichever are their funding agencies, and they get very well optimized for being able to market to that customer. They're really good at latex in writing up their research reports, and they're really good at writing proposals to the National Science Foundation and things like that. And so then trying to be distracted and trying to build awareness. So, do you think, for the clients that you work with the scientists and communicators that you're working with, does helping with the popularization and helping with awareness and getting the word out help them with that first job? Do granting agencies take that kind of stuff seriously and see it as a benefit, or do they see it as a distraction?
Well, taking it seriously is kind of a great question. If you get a grant from the National Science Foundation, within that grant comes the responsibility of showing, how you're providing broader impacts, right? So that's a requirement. Very few actually build out anything substantial to show what the broader impact is.
Right.
It might be a PowerPoint or a Word document, and some kind of a post-grad is writing it or what have you. It's not necessarily being checked either on the side that's offering you the grant requiring it. So it's that showing broader impacts has just kind of languished for a while, and it doesn't seem to have been an important part of that. So we are where we are now because of kind of that lackadaisical requirement. So it's time to step it up. So,
yeah.
and how do you do that? Again, not all scientists and researchers are great at developing websites, and telling the story through that channel. And then how is it connecting with the public based on what you want them to know about your science? Because the jargon is not necessarily going to invite people in warmly, when the terminology is way over their heads. And how do you relate to that? How do you relate to the public who really is probably more so interested in the science fiction than they are in the science? But as we say, you need to start with the science fiction, and open the doors for them to discover the science for themselves.
Well, let's talk a bit about science fiction, which is that we're sort of in this golden era now of mainstream media production houses, the Marvel and Disney and a lot of these big groups, Lucasfilm. I guess that's all the same company, isn't it? Anyway, they are creating content that I guess sort of fulfills the expectations of what the fan of this genre has always hoped for. The movies coming out of Marvel, the Doctor Stranges and the Avengers, and they're getting good directors, they're getting great special effects, they're telling really good stories, they're kind of nailing it on every single front. Disney, you're welcome, sponsor me. But I guess the point is that like from the science side, still we as science fans are not getting that level of I don't know, almost respect. We're starting to see it, and we're starting to see, I hope, that the media companies are seeing, we can make The Martian, it can be scientifically accurate and teach and be super wildly entertaining and teach people about space exploration. We can have a TV show like The Expanse, which is fairly scientifically accurate, except for that engine system, but fairly scientifically accurate, and have and be wildly entertaining, and then we can have shows like Cosmos, and we can have like Planet Earth 2, which is just mind-bending cinematography on top of explaining biology. So, do you think that we're moving in the right direction, or are we still going to be
I absolutely. No, I do believe that we're moving in the right direction. And I also believe that we are being moved into that right direction. And one of the other things we like to say is creativity is gravity for us. And I think that, given the political climate, no pun intended there, is that we are being forced at this point to either be involved in the debate or let the non-scientists and the non-experts dictate the policy, which is a very different and kind of dangerous thing in a lot of ways. So yes, I do think that we are moving in the right direction. I think that we need to just find ways of connecting more, bringing the science into the science fiction in those popular realms where people are viewing, people are having an opportunity now to discover a little bit more about astronomy, big announcements that come out of NASA about exoplanets recently. That's incredibly exciting. Are we ever going to be able to land on that planet anytime soon? Well, of course not, because we haven't discovered the science that gets us there yet. Mm-hmm. But you really aim very high, and you have these great goals that motivate you to continue learning. Just yesterday, Congress is going to give NASA a huge bump in budget for its deep space science. However, it's going to come at a cost. So
planet.
Yeah, right. Yeah. Exactly. And all of the evidence of everything else that we know about the universe, maybe not all of it, but most of the evidence of everything we know about the universe is right here on Earth. Mm-hmm, right. Mm-hmm. And if we do not necessarily turn our attention to finding those clues here on Earth, we're not going to know necessarily what to look for out there in space. Tell people that, change your perspective a little bit, in that we are not a small planet in the universe. We're the universe on a very small planet.
Now, you sort of came to this show via our good friend Dr. Paul Matt Sutter. So can you kind of explain the way you guys work together, and maybe how you're helping Paul and theoretically other science communicators to get the word out and maybe even make a living from their job?
So I actually have only a small handful of scientists that I work with directly. Mostly I work with groups or institutions, universities, and those are very different kind of goals, very different budgets, of course. Paul had reached out to me and was asking me about, how can I reach these certain types of goals? How can I do this?
How do I do this? How do I do that? That's classic Paul. Yeah.
Which I think is interesting, because Paul is, I think, exceptionally talented in his podcasts and his YouTube series and his writing and his articles. And Paul gets the idea of creating science experiences really, really well, more so than a lot of other scientists I know, because your research story is your story. But there are so many different channels that you can tell that story. And the story doesn't necessarily change, but the way that you tell it should change, because the podcast audience is very different from a YouTube audience. And when that YouTube audience then discovers, hey, he's got a podcast, so then they go hear the podcast, but then they're getting reinforced with the same information. But because it's a radio show, it enjoys the benefits of the pictures are much better in radio sometimes, right? Because the mind, you as an individual, as a listener, get to develop your own visuals, and then it becomes very personable. That's what makes a science experience, and Paul gets that. So what we decided to do, because not everybody has, 10,000, 20,000 a month or whatever, to engage in developing these communications and video and all these things. Paul let me know what his budget was, and I said, you know what, I got to work with this guy. He's a great personality, great character. We hit it off in conversation very quickly. And this is, frankly, who do you want to hang out with every Friday for half an hour on the phone, right? In fact, our phone calls tend to go a little bit longer than that. And there have been times where I've seen something, and over the weekend, I want to give Paul a call, just like I would like any of my other friends, and say, dude, guess what I just checked out? So we do that. We have those conversations based on where I know where he wants to be, what his goals are, the work that he's doing, the events that he's a part of. When I learned about the trip to Iceland and those, there's just, those conversations are where the opportunities come up, because science, business, any other industry, it's about people, connecting with other people. It really is.
Mm-hmm.
And how you tell that story of your science, it's critical. The way Paul tells his stories about science, those are critical connections that you make.
So what are some projects that people might have seen or that you've been involved in and sort of helped bring to audiences?
Right. Well, Spacetime Labs is still very young. We're just about a year old. It's a constant research for us into who our clients are, constant research for us into the public and what they crave and what they need, what they want to see. Recently, the last couple of projects we worked on with the University of Nebraska in Lincoln and WNET Nebraska, which is the PBS member station, PBS NPR member station in Lincoln. That first project that we worked on with them, they were telling the story through this documentary, telling the story of the history of paleontology across the plains, specifically Nebraska, but of course, there's much more outside of that. And they wanted to have an online learning companion to the documentary, because in an hour or 2 hours of video, you only get so much of the history. There's so much more story to that. So having something that was more interactive, talking not just about the fossils that they find and why they're there in Ash Falls and some of these other fascinating digs, but the history of the paleontologists themselves. And very early on to present day, the work that they're doing, people don't necessarily understand the difference between an epoch and an era when it comes to geological time, and most don't understand geological time. But if you can interact with it, right, sliders and questions and the timeline, then it becomes a little bit more personal, right? Then it becomes your science and not necessarily just something that somebody else or a group of people are studying out there. Plus, we also had a requirement within this project for PBS Learning Media, their online curriculum resource for teachers. So we developed some material to serve that need, as well as the STEM initiative for the state. So and really to make it more interactive, to make the story more interactive. To show that it's as much about people as it is about old bones, and let people, discover it on their own and decide which story connects with them and their identities.
So if people want to find out more, I showed your website briefly. I'll show it again right now. But where can people find out more, sort of about what you're working on, and if they are looking to, communicate their science a little better, where should they go?
Well, spacetimelabs.co is our website. There are examples there. We just recently released a little bit of a teaser video on the heels of the TRAPPIST-1 announcement. This was not necessarily to tell a news story or to be a video's news release. It was to take fascinating news of the day within 24 hours and turn it around into a small piece of video. That is something that any research group can do. It's very easy. All it takes is a decision, just a little bit of time, and a goal, focusing on a very, very simple goal as to what do you want people to do, right? You can go to our website. You can find us on Facebook. We're also on Twitter. Connect with us. Let us know what your challenges are. For those who don't necessarily have any budget at all, that still want to, find out, how they can learn things, we have what we call our lab. We do this for all of our clients. We create a very specific client lab page where we keep notes on all of our conversations and different files and trade resources back and forth. But we wanted to create something for the public as well, or for scientists who aren't our clients yet. And you go to spacetimelabs.co/thelab. And there are plenty of resources to learn more about brand strategy and communication strategy and how to create design. There are great resources there for you to use design templates, so you don't necessarily have to create everything from scratch on your own. There are some great videos on how people are motivated and what do people want to see on social media and anywhere else. So there's a lot of great resources there. Plus, down at the very bottom of the page, we offer an opportunity for scientists and researchers and the public to ask us for something specifically that they don't see on the lab page, but they really desperately need. We'll definitely respond to that as quickly as possible and send them an update and let them know, new resources available, go check it out.
Awesome.
One of the best examples of a great science experience and how it connects with individuals on a very personable level is there's a video there from a group in the UK called Momondo, very similar to like 23andMe and Ancestry, but they had this fantastic marketing campaign where they brought a bunch of random people into a group and took DNA samples and went off and wanted to show them where they really come from. But there's a little bit more to that story in some of this, and you just got to go watch it. I mean, it's a science experience, and it's very personal. It's great.
Fantastic. Well, I know, Nick, you're going to stick around while we we run through the news. So thanks again for joining us. And
absolutely, thanks for having me.
I couldn't agree more on this idea of branding. And I know sort of for most people, this idea of branding is this sort of corporate speak that explains, how to sell more of your product. But really, brand is just helping people get a better sense of who you are and what you do, and being able to feel like they know you and they trust you. And that's sort of what we do here in the Weekly Space Hangout with all of these scientists, is that week after week after week, people are getting a better sense of who they are and what they do and what they're good at. And I hope at the very least that each one of these will be getting interviews on television shows and getting their own documentaries and National Geographic and all that, because they have demonstrated a capability that they can give presentations, that they know their stuff. So awesome.
Brand is a conversation that happens over time.
Yeah.
Right? And it grows in value over time. We don't necessarily say that we have to do everything for you. Of course, we want to help all of our clients, and develop these things. But look, we also want to teach them how to do it for themselves too. We want to teach you to be sustainable and scalable in that work. So we'll be launching online learning fairly soon. We have a webinar coming up in the next couple of months. We want to be able to help the research community do it on their own for themselves as well.
Awesome. Well, thanks, Nick.
Thank you.
Let's move on to the first of our stories. I choose. What did I say I wanted? Oh, right, Kimberly. We're going to talk about the Europa Clipper. That's right. I wasn't going to go first, but now I think I want the Europa Clipper.
Sorry, Morgan. Just yesterday, NASA got approval for an official name for their Europa flyby mission. It is now called Europa Clipper, after the series of sleek and fast transoceanic trading ships that were prevalent in the 19th century. And this Europa flyby mission, which is completely separate from any sort of Europa lander mission, got official approval for Phase B development on February 27th, which means that the scientists can start putting together a preliminary design for all the systems and subsystems and begin exploring, prototyping and selecting vendors for all their subsystems. This Phase B development for Europa Clipper should be ongoing through 2018, and then they'll hopefully get approval to start building so that they can launch at their goal launch date of in the early 2020s, so they can arrive at Jupiter in the late 2020s. So
yeah. So what is the mission profile as it's been figured out right now? So
the mission profile right now is to put Europa Clipper in orbit around Jupiter, such that it completes an orbit about once every 2 weeks. And given Europa's orbit, it'll be able to complete 40 to 45 really fast flybys of Europa. They don't want to put they don't want to put Europa Clipper in orbit actually around Europa, because Europa exists in a very radiation high environment that would damage a lot of the really sensitive instruments that they want to put on the flyby. Just for a sense of scale, Europa at orbital distances receives about 3,900 times the amount of radiation that someone at sea level on Earth receives. So it's very radiation high, very damaging to any sorts of sensitive instruments that they want to put on. So we're only doing 40 to 45 flybys of the surface.
So it's just going to zip in,
it's going
take
to
a bunch
zip
of
in,
observations, and get
past.
back out again.
Yep, and then come back a few days later. But because of that, they're putting actually very powerful instruments on the flyby craft itself. They've settled on 10 of them, which include high-resolution imagers in ultraviolet, invisible, and infrared. They have ice-penetrating radar. They have magnetometers. They have mass spectrometers to get composition of the atmosphere and any dust particles that float up. So they're really trying to optimize the power of this flyby craft. And to do that, they need to keep it out of the radiation hot zones.
Is it going to have a European space whale detector?
No, I don't think so. Unless you can get, nice, good radar imaging, like at different oceanic depths, maybe. Ping off a
something to ping. It depends how big they are, right?
But ping off the ocean whales. Why not?
But one of the instruments, and this is sort of the experimental one, is that it's going to have this penetrating radar that's going to help try to look below the ice, right?
Yeah, exactly. So the subsurface ocean on Europa, we're pretty sure that it's there based on magnetic measurements and gravitational measurements of Jupiter and the 4 Galilean moons. We're pretty sure that it's there, but we still want to be able to look underneath the ice to see, how salty the ocean is. Is there any how deep the ocean is? How deep the ice crust is? There's all sorts of unknowns that we're still trying to figure out, and that's what this radar will help with.
I know this isn't your story, Morgan, but as a researcher who works on Saturn, ice, planetary stuff like this, on a scale from 1 to incredibly excited, how excited are you about this mission?
This would have to be like a 9. This is maybe the first time that we're sending a mission somewhere to a world that might actually have life today. We've been studying the heck out of Mars. Mars may have had life in the past, but not today. Cassini's been studying Enceladus and Titan, but from a distance. This will be the first time that we will begin to understand a world that one day we might be able to find evidence for life on. And the Europa Clipper is not really equipped to do that, but it's equipped to make all of the sort of survey observations necessary to figure out, okay, if there was access to the subsurface ocean, where would that be? And if we wanted to land there, where exactly would we have to go? What kind of environment would we be facing? And so the Clipper is really going to be a pioneering mission to lead the way for the lander that will surely come to follow that.
Kimberly, I mean, as an exoplanet researcher, how does Europa sort of fit into the kinds of worlds that you guys are looking for, and how does planetary exploration in our solar system help you with a lot of the work that you do?
So it really helps by, confirming that other environments outside of Earth are capable of hosting life. Because we know here on Earth, life will exist just about anywhere where there's water, but outside of Earth, that's completely theoretical. Is it possible to create life elsewhere? Is it possible to create subsurface life that does not see any sort of solar radiation, which opens up, all sorts of worlds outside of the habitable zone as well, that may have icy surfaces but may still be internally heated somehow? It opens up moons of other planets, exoplanets that could host life, just like Europa may. It even opens up a little bit some of these free-floating planets. Maybe they're still internally heated, but they don't have any solar radiation. So really, it's a proof of concept.
I mean, one of the things that's pretty exciting is how these worlds, I mean, not just Europa, which has got this tidal interactions with Jupiter, and it's being kept kind of flexed all the time, and that's helping with it. But there's more and more evidence that there could be under ice oceans at Ganymede and Enceladus.
Right, Europa is definitely not the only moon in our solar system that has subsurface oceans. Yeah, even Pluto. Yeah. There's some evidence that underneath the icy surface there is either, water or slush of some sort.
Now, what about landers?
Landers are still pretty far off, and a lander will have to deal with a lot of challenges just on staying on the surface and staying safe on the surface due to all the radiation that it's receiving. Let alone if it wants to drill down to actually access the ocean. We have no idea how thick the ice is. We don't have good topological maps of the surface of Europa. So would it be a rover? Would it be stationary? We don't know what the capabilities would be, what the possibilities are.
Right. So next step, orbiter. Step after that, lander. Step after that, rover.
Yeah, if we can develop the technology to actually stay around Europa and, have good continuous measurements that'll survive, that's the next step. Right now, we can only sort of like dip our toes in, like one flyby at a time.
Right.
Before, radiation kills the craft.
Yeah, well, I can't wait. This is going to be
I'm really excited.
One of the most exciting missions that are in the works, and I really hope that everything goes through.
More than a decade out, I'm still already excited.
Yeah. Well, it's funny. We just did a video about Cassini, saying goodbye to Cassini on our channel, and that's been rolling for like 17 years. Like it's like literally my whole career as a journalist has been telling the story of Cassini from launch through the flyby, through flying out to Saturn, to observing Saturn, and shortly to dying. And these things take time. New Horizons, same thing. So we got to be patient. We'll get our science over time. All right, let's move on. Next story now. I want to know about these new images of Pan. Paul Metz-Sutter.
Yeah, Pan. But first, I just want to say, Nic is an amazing guy. I've been working with him for a few months now, and I reached out to him because I'm a trained scientist. I am not a trained science communicator, and recognize the fact that I have a lot to learn, and Nic is helping me make sure that I do my audiences right.
Well, thanks a lot, Paul. I really do appreciate that. And it's got to be one of my favorite conversations each week, because I learn an awful lot about the science.
Well, you should make this a podcast.
Oh,
that's my instinct.
Wait a minute.
Yeah. If an interesting conversation is being had, my first instinct is like, let's just make this public so other people can watch it. So, but Paul, let's talk about Pan.
Yeah, Pan. So Cassini has released these very detailed close-up images of the second innermost moon of Saturn, called Pan. And there's all sorts of metaphors out there. It looks like they say it looks like a ravioli, like a dumpling, like an empanada. I have not seen the word pierogi thrown around, but that would be my preferred metaphor for Pan.
Yeah,
a frozen pierogi.
Like a gnocchi or something, maybe.
Yeah, there's maybe some potato-y kind of dumpling pasta.
I'm just displaying it on screen right now.
There we go. So it's very small. It's just like 20 or 30 miles across. And it's made of ice, but you'd see these distinct rings of ice on the surface. And that's because this little moon or moonlet sits within the rings of Saturn and actually clears out a small gap, the Encke gap, within the rings. And all that material naturally accumulates on the surface. But since the rings of Saturn are so dang thin, they just pile up in a little layers of rings on that little moon Pan, instead of just piling all around the surface to make it. And Pan is so small that it doesn't have enough self-gravity to make itself round, so it can end up with these really weird features, which look pretty cool.
Yeah, I'm gonna show some more of this animation. I got the one from the tweet from Cassini Saturn, and it's just
where it's kind of showing like a little flyby.
Yeah, it looks like a UFO maybe, or it's pretty amazing. I dig it. It's sort of a similar situation to what happened with Iapetus, right? That's one of Saturn's other moons that is gobbling up a whole ring and getting bug splatted on the one side, and then is, pure as driven snow on the other side.
Yeah. The more we learn about the relationship between the rings and the moons, the more surprises there are, the more complicated the physics are. This is actually a very, very complicated astrophysical disk system, rather than just a nice steady state set of rings.
But I think it looks almost exactly like what in the 50s they thought the future would look like. Planets with like these solid ring disks around them. It's been foreseen.
I mean, yeah, you take this, you take the latest
Jetsons.
TRAPPIST results. It's just all we need to know about the universe. We can go back and look at the covers of 1950s sci-fi novels, and that's pretty much reality.
Yep, perfect. All right, well, let's move on to the next story. We're going to talk about Blue Origins. Okay, am I going to be able to order Amazon from the moon, Morgan?
One day, but I'm not sure this will be the rocket to do it for you. We talk a lot on the Weekly Space Hangout about SpaceX and the Falcon 9 and the Falcon Heavy and other projects from Elon Musk and company, but they're not the only upstart company in space launch systems. Blue Origin, founded by another tech billionaire, Amazon's Jeff Bezos, was actually the first company to successfully launch and land and launch and land and launch and land a useful rocket. And this was with their New Shepard rocket that, starting a couple of years ago, was making suborbital trips and is intended within the next year or two to begin carrying tourists from the ground up to space, or past the edge of space for a few minutes of weightlessness and then back down to Earth. And it's named after Alan Shepard, the first American in outer space whose trip itself was very similar. His entire rocket ride was only about 20 minutes long. Right. And that's exactly what New Shepard was designed to do.
They tell the story in Hidden Figures. I don't know if you've seen it yet, but they did a great job of that.
The next rocket, though, is going to be a lot bigger. And they're calling it New Glenn, after John Glenn, the first American to orbit the Earth. And that's because this is a rocket designed explicitly for launching material into low Earth orbit. And it's going to be able to do a lot of that. When it flies by the end of 2019, New Glenn will be able to lift as much as 45 tons into low Earth orbit and as much as 13 tons into an interplanetary transfer orbit. And that's going to place it sort of comfortably between what the Falcon 9 can do now and what the Falcon Heavy will be able to do if it begins launching later this year.
But it's so much bigger than the Falcon Heavy. It's a gigantic rocket.
Yes, it's a much larger structure, and they haven't obviously released many details about how they're engineering the rocket, but we can look from the pictures and see that one design decision that they made differently from SpaceX was not to have these sort of add-on boosters on the side. And those boosters can often allow you to make a smaller rocket because you fire those boosters kind of like the space shuttle, and then you can detach them. And lose that weight, and then you don't need as much fuel in the main stage because you're not lifting as much weight. But that comes with its own set of reliability trade-offs, and clearly Blue Origin has chosen to go with a more traditional integrated system. And because of that, they're targeting New Glenn to be able to launch and land 100 times for every rocket. Now, that's a really ambitious milestone to try to reach, considering that New Shepard has only launched and landed a handful of times, and it's not coming down from the much higher velocities that the first stage will reach when coming from a much higher orbit.
Yeah, and we're going to talk about the next stage for SpaceX, of course, because we need to report on every little thing that Elon Musk does. But when Blue Origin first did that launch of the New Shepard and sort of did the reuse, and they did another one, and they did reuse, it was sort of laughed at because it's not a real orbital rocket. This is easy compared to going to orbit and then returning your booster. But the New Glenn is a serious machine. This is going to be the thing that's going to take satellites to orbit, lift an enormous amount of capacity. Where do you think we are along that development curve? When do you think we're going to really start seeing a proper battle for orbital launch services?
Yeah, if New Glenn was flying today, it would be the most powerful rocket currently in use. And so I think some of the skepticism that the traditional aerospace industry has leveled at these sort of Silicon Valley-esque rocket companies is in the enormous leaps that they're taking. To go from a rocket that doesn't even reach orbit empty to one that, if flying today would be the most powerful rocket currently available, that's an enormous step. And just like going from the Falcon 9, a orbital rocket in its own right, to the Falcon Heavy, which will be the most powerful rocket flown since the Saturn V, that's another tremendous jump. And so what we're seeing is that very soon, either this year or next year, or certainly by, say, 2020, we're going to have available to us a lift capacity that we haven't had since the Apollo program. And it's going to be cost effective enough that we can use it for things that we would never have dreamed of using the Saturn V for. We'll be able to launch a large number of satellites all at once. We'll be able to launch pieces for new space stations. We'll be able to launch payloads to the moon, to Mars, to asteroids in the asteroid belt, in ways and at costs that we've not been able to do for decades.
Yeah, I think I'm just panning through this gallery on Ars Technica of the different pictures of the rocket system, and as you said, I mean, not only are we going to have a significant reduction in cost, we're going to have a capacity that's never been seen unless it was the Saturn V, and competition. Like, this is space exploration nerd Christmas right here. I mean,
it's amazing to think that a decade ago, none of this existed.
Yeah.
10 years ago, SpaceX was just sort of starting to test their very first rocket engines. And if you wanted to get to the space station or into orbit, you had to rely on the Soyuz from the Soviets, or from the Atlas V from the United Launch Alliance, or maybe from the Ariane 5 from ESA. And that was it. You had to go through a major government or government contractor to get access to space at all. And 10 years later, we're not talking about one or two other opportunities. We're talking about 3 or 4 or 5 different ways to get into orbit, untethered from any nation and untethered from the hundreds of millions of dollars that was necessary in order to make that access happen just 15 years ago.
Yeah, and so we don't know. I mean, what are we going to use those rockets for? We don't know, right? Like, we can assume it's going to be satellites, but at the same time, satellites are miniaturizing. So it could very well be that in the future we launch a fleet of planetary exploration satellites all in one go, and off they go.
India just a couple of weeks ago launched 110 satellites on the same rocket. Now, those aren't interplanetary class satellites, but that capability exists today. And when these new launch vehicles come online and when they sort of become cost effective, I think it will open up opportunities in space that really haven't been seriously considered before, because it just seemed too pie in the sky. And now it's going to be possible to undertake projects that you might not have previously imagined undertaking.
We got a question just from the chat from Larry Beckham. Hear anything about Blue Origin reusing the second stages? So, this, like SpaceX, is a reuse of the first stage, but some of these rockets are going to have a second stage for the New Glenn. Do you know if they have plans to reuse other stages?
I don't believe so at this time. Reusing higher stages is a really challenging thing to do because first you want your rocket to be light. And that means that the upper stages tend to have a minimum amount of fuel in them, because fuel is one of the sort of heaviest components of a rocket. And second, the upper stages are used naturally higher in the atmosphere. And so when that stage sort of burns out, it has a lot farther to fall. And gravity's pulling it the whole way, and it's speeding up more and more and more. And so we've seen that even with the Falcon 9, when SpaceX is forced to launch payloads to certain sort of extreme orbits, they have to push the first stage so hard that they don't even have enough fuel left to slow that first stage down and land it back on land. And those problems are just exacerbated when you get to higher stages.
Yeah. Well, I am super excited by the competition, and I really look forward to the next few years. If this all goes as planned, we're going to see so many spacecraft, so many missions. It's a pretty exciting time. All right, let's move back around. Kimberly, let's talk about ancient stardust detected in a distant galaxy.
Great. So astronomers at ALMA and the VLT have detected a very, 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 very distant galaxy many varies.
That's a lot of varies, yeah.
It's very distant. This galaxy contains a staggering amount of interstellar dust. Now this galaxy, when I say it's very distant, it exists in a place that when we're observing it, it's only 600 million years after the birth of the universe. So this is the farthest thing that ALMA has ever seen. And the fact that this galaxy has so much interstellar dust, which can only be created through stellar fusion and then supernova, it means that this galaxy has gone through multiple generations of really fast star formation.
Already.
Yeah. The universe is 600 million years old. It takes approximately 200 million years for a star that massive, to get born, process all of, its hydrogen and helium into the materials that form dust, silicon, carbon, aluminum, and then for it to die, that's a 200 million year process. So already at a universe of 600 million years old, there's already been multiple generations of star formation. And that's really one of the, big holy grails of, trying to put together the timeline of the universe is when did the first stars ignite? And we're still chasing that. And this discovery with ALMA and VLT shows that, even so far in the early universe, there's already been multiple generations of star formation.
Right. And so our own, for example, sun, they call us like a third generation star. We've already been through multiple generations of supernovas, big stars forming, exploding, seeding the area, other stars puffing out their outer layers as they die. But that first class of stars, the pop 3 stars, the ones that form just out of the pure hydrogen helium from the universe.
Right. We don't know exactly when those stars first started forming.
And we don't even really know their size, right? I mean, we don't know really.
We know that they must be a lot bigger than even the most massive stars that we see in our Milky Way. We know they have to be so much bigger because they don't contain all these other elements, anything heavier than helium or lithium. The more and more of that material you add, the more energy you can dissipate through the star, so the star can actually contract and get much smaller. But in the early universe, those elements didn't exist in the same quantities that we have now. And so stars, physically could not get smaller than that. They couldn't, when they collapsed from these large interstellar clouds, they just couldn't get smaller than, a few hundred solar masses or so. So we know that they must be much bigger. They must fuse hydrogen at a much faster rate than anything we see in our Milky Way. They must die a lot faster. And so you'll go through multiple generations of star formation even before, this 600 million year galaxy that we just discovered.
We got a question from William Van de Beek. Does this distant galaxy fit within the Big Bang Theory? And I guess the question is, to modify that a little bit, does this discovery sort of, how would this change our understanding of the early universe? Does this support mainstream theories?
Oh yeah, it fits very well within the Big Bang Theory, definitely.
Yeah,
it fits very well. At the distance that it is at its current age, it fits right in the middle of the reionization period. And actually, part of this detection was also the detection of ionized oxygen, which is the most distant detection of ionized oxygen we've ever seen. And this galaxy fits right in the middle of that reionization period, where we know that there's a lot more radiation that's ionizing all this intercluster gas, all the intergalactic gas and things like that. And so it fits very well.
Wow. Space Today just donated, which is like literally the first time that's ever happened in the whole Weekly Space Hangout crew. So thank you. You've paid for our internet for today. Well, that's awesome. That's awesome news. And I mean, this discovery was a bank shot, right? I mean, they used gravitational lensing to even spot this.
Yeah. No matter how powerful ALMA and VLT is, they would not have been able to see something this distant, except for the fact that this really distant galaxy lined up pretty perfectly with a really massive galaxy cluster, Abel 2744. Okay. But this really massive galaxy cluster essentially acted as a magnifying lens, magnified this really distant galaxy about 2 times, so it appears about 2 times larger than it actually is, and that's the only reason that ALMA and BLT were able to appear that far away.
Amazing. All right, we're starting to run out of time, so let's move on to the next story before we get there. I choose the origin of the Milky Way's Fermi bubbles, and I don't even know what that means, Paul.
You've never heard of the Fermi bubbles? Oh, they're the best bubbles ever. Our Milky Way galaxy has at its center a supermassive black hole, which we call Sagittarius A star, and it has a mass of a few million times the mass of our sun. And supermassive black holes, when they're quiet, when they're not doing anything, they're just hanging out there. But every once in a while, gas or stars or whatever can fall into a supermassive black hole. And when that happens, an accretion disk forms, complex astrophysics happens that I'm going to skip over. And some of that material can get wound up and ejected into long, thin jets. And we see these in the distant universe. We call these quasars, or quasar-stellar objects, or blazars. There's a few different names for them, or active galactic nuclei is another name for them. So our Milky Way galaxy isn't really doing anything active right now, but it did in the past. And there are remnants of these outbursts sitting outside the plane of the Milky Way galaxy, these massive, very thin, but very hot bubbles detected with the Fermi Space Telescope, hence called the Fermi bubbles. These things are tens of thousands of light years across and have very hot temperatures like 20,000 Kelvin, but very thin, very diffuse gas. And this was detected a few years ago, just evidence of them existing. But with some follow-up observations with Hubble, astronomers were able to figure out the speed of the flow of gas. And it's somewhere in the millions of kilometers per hour range, the speed of these outflows. And then you run the clock backwards and you can figure out the last time that our supermassive black hole had a snack and burped. And that was about 10 million years ago.
Wow.
And that produced these bubbles.
That's amazing. So we can find out how often the supermassive black hole at the heart of the Milky Way has been feeding by just seeing these
remnants.
Space farts. I don't know. Moving out into space. That's one
of two ends. Well, there's one on each
one
end.
on each side. There's one above and one below the Milky Way. So yeah, exactly. That's fantastic. No, so does that match the theories about how often our supermassive black hole is in some kind of feeding phase? What is how often are these things thought to happen with the Milky Way?
Yeah, with the Milky Way, we honestly don't know. With active galaxies with different distant quasars, we can actually see trains of these bubbles separated by about 100 million years or so. But for a normal kind of quiet suburban galaxy like our own, that's a big question of just how active is it and what is causing the feeding frenzy. What caused it 10 million years ago? When's the next one going to happen? When was the one before that? All this ties into questions of galaxy evolution, galaxy formation. That's a big open research topic right now.
So back when that was happening, would we have been a quasar to some other distant alien galaxy?
I don't know if we would have been bright enough to be classified as a quasar, or if there's a galaxy 10 million light years away from us and they're just now seeing the light. We would have maybe appeared mildly active, but not maybe active enough to be classified. We don't quite know the total energy of this outburst event from 10 million years ago.
Oh, absolutely fantastic. That is really, really cool. All right, we've got one last quick story. We, of course, have to say something about Elon Musk every week. Morgan Renberg, this is your job.
If you had to criticize any aspect of SpaceX's Falcon 9 sort of strategy, it might be that they've landed a whole bunch of these first stage boosters, but they haven't launched any. They've been landing them now for more than a year, and they've got a warehouse basically full of them.
And while
Blue Origin has been launching and landing the much smaller New Shepard. SpaceX has been sort of studying the Falcon 9s that have been returned and testing them, but they haven't ever launched one. And that's going to change this month, because by the end of March, SpaceX will relaunch one of these previously landed Falcon 9s for the very first time. And they'll be launching a satellite for a company out of Luxembourg called SES. This is a sort of a past customer of SpaceX that has expressed interest in being one of the first companies to get a chance to launch on one of these reusable systems, which would presumably net them a hefty discount.
Yeah, they get a discount for using
for
rocket?
taking on that risk. But if this goes off without a hitch, it's a realization of the last few years of talking about being able to launch things and land them and launch them again in an actually meaningful scale. We're talking about sending stuff to orbit. That's the daily bread and butter of the launch vehicle business. And to be able to actually sort of carry out typical operations with these relaunched vehicles will prove whether or not this is a plausible idea that they've been chasing now for a few years or not. And clearly they believe that this is the future and that this rocket is ready and it'll perform exactly as an off-the-shelf brand new Falcon 9. But until you actually make that launch happen, and then you try to land it again for the second time, you won't really know for sure if all of your calculations, all your theory is going to play out.
And, I mean, do we know how many reuses these things are expected to be able to do?
So SpaceX has for a long time also talked about this sort of goal of 100 launches and landings, but I don't think there's the expectation that these sort of first generation Falcon 9s are designed to do that. And there's even been some rumor in the industry that suggests that after sort of taking a look at what these rockets look like on the way back, that they might be sort of tamping down their internal expectations for how many uses one of these Falcon 9s might ultimately take.
But I guess theoretically, right, every time you launch one of these, you bring down the rocket, you look at where it's breaking, and then you redesign the original new rockets to be more structurally sound in those places where they're seeing weaknesses. You can incrementally move towards a reusable rocket system that just lasts longer and longer and longer. I mean, it took decades for airplanes to be as reliable as they are today, for cars to be as reliable as they are today, and the only way you find out is by pushing the limits. And so, very brave of SES to be one of the first guinea pigs. I'm sure they're not putting a satellite they really care about on board this one yet.
Yeah, you can imagine that knowledge gained from the Falcon 9 landing program has already been incorporated into the design of the Falcon Heavy, which is certainly a much more massive rocket that's going to have to be slowed down to a landing speed. And both the Falcon 9 experience and the upcoming Falcon Heavy experience will be rolled into designs for the interplanetary transport system, as well as whatever successor rocket to the Falcon 9 eventually gets unveiled. And once you have this experience at the small size, experience at the medium to large size, you'll really be able to understand the stresses that atmospheric reentry sort of places on these rockets and design appropriately to mitigate as much of that as possible.
In the chat, Zach Cody said, this is your Musk Minute with Morgan. It's longer than a minute, but I like the way that sounds.
I don't think I've ever talked for just a minute in my life.
All right, well, I think it's time to wrap things up. Before we do, I just want to remind everybody, big thank you to the WSH crew. This is, of course, the community behind the scenes, working hard. They're the chat down here. It's free to join. You're going to love them. So go to wshcrew.space and you can join this community. See, now they've got the domain name that I can remember. It's all very easy. So join them. And then you get to be one of the executive producers of the Weekly Space Hangout. Got a guest you want? You want to try and land someone from NASA? Or if you can get Elon Musk on, I'd be glad to interview him. All right, let's give people a chance to find out more. I've got Morgan Renberg on the screen right now. Morgan, where do people find out more?
Yeah, you can visit me on Twitter at Morgan Renberg, where I was gushing about those pan images this week.
Yeah.
Or you can check out my website, morganrenberg.com.
Awesome. Kimberly, where do people find out more?
People can always find out more by following me on Twitter at AstroKimCartier and at my website and blog, KimberlyCartier.org.
Paul Matt Sutter.
Hey, you can follow me Twitter and Facebook at Paul Matt Sutter. It's my name. And also pmsutter.com has links to all the stuff I do, including Ask a Spaceman, my very fun podcast, which is full of information.
Right on. And of course,
I need to work on a better tagline.
Well, that's why you talked to Nick, I think.
Exactly.
Nick, where do people find out more?
People can find out more at going to our website at spacetimelabs.co. And one little trick that you can try for yourselves at home or online, do a Google image search for the word technology. And you see those results. Do another image search for the word science. You'll see the difference in the work we're trying to do.
That's fantastic. All right. Thank you, everyone, for joining us this week. Thanks so much to our special guest. Thanks to Elon Musk and Bezos for continuing to advance space exploration. All right. We will see you all next week. The Astronomy Cast is going to be happening in about 20 minutes. So shift over to that channel and go ahead and join us there. We're at the big collection view now, so everyone wave goodbye. Goodbye.
Bye.